At first, astronomers thought it was just another dot, another faint speck drifting across a noisy background of stars. Nothing unusual, nothing alarming. But within hours, that assumption collapsed. Because the moment scientists calculated its motion, the data refused to make sense. The object was moving too fast, its trajectory was wrong, and the numbers kept getting worse the more precise they became. This was not a comet returning from the outskirts of the solar system, not an asteroid nudged by Jupiter. This was something entering our neighborhood from a direction no normal object should arrive from, something that did not belong to the sun at all. In 2017, the discovery of Oumuamua shocked astronomers by proving that interstellar objects exist. In 2019, Borisov confirmed it wasn't a one-time event. But both of those objects fit loosely within expectations. Small, faint, difficult to study. 3I-Atlas does not. This object is brighter, larger, faster, and far more disruptive to our models than either of its predecessors. When the Atlas survey detected it during a routine scan of the galactic plane, nothing initially stood out. But when older images were reanalyzed, astronomers realized something unsettling. This object had already been observed weeks earlier by multiple telescopes, hiding in one of the most crowded regions of the sky. It had gone unnoticed not because it was faint, but because it was moving through a region most surveys avoid entirely. Once those observations were combined, the orbit solution left no room for doubt. The object was on a hyperbolic trajectory with an eccentricity close to 6. That number alone stunned researchers. Anything above 1 means the object is unbound. 6 means it was violently ejected from its home system and is now passing through ours at enormous speed. That realization earned it the designation 3I-Atlas, the third interstellar object ever confirmed. But the shock didn't stop there. As more data arrived, scientists noticed a faint glow surrounding the object, a coma, a thin halo of dust and gas forming as sunlight reached its surface. This wasn't just an interstellar rock, it was an interstellar comet, and unlike anything we've seen before, it was behaving in ways that didn't line up with existing theories. Scientists weren't just intrigued, they were genuinely unsettled. Because if this object is typical of what's drifting between stars, then we may have fundamentally misunderstood the population of interstellar space. One question was answered immediately. 3I-Atlas is not dangerous to Earth. At closest approach, it will remain far beyond our planet's orbit. But danger was never the point. Speed was. And 3I-Atlas is moving at roughly 58 kilometers per second relative to the Sun. That makes it the fastest interstellar object ever observed entering the solar system. To put that in perspective, Oumuamua entered at about half that speed. Borisov was slower still. This is not a subtle difference. It suggests a radically different origin story. Objects do not reach these velocities by accident. They are accelerated by extreme gravitational events, close encounters with massive planets, chaotic multi-star systems, or violent early galactic environments. And whatever flung 3I-Atlas into interstellar space did so long before our solar system formed. As astronomers traced its path forward, they found that on October 30th, the comet will pass just inside the orbit of Mars before curving sharply around the Sun and accelerating back into deep space. It will never return. That makes every observation critical. But what truly baffled scientists was what they saw when they looked closer. For an object of its size, 3I-Atlas is surprisingly restrained. Its activity level is modest. There are no dramatic outbursts, no massive jets, just a faint coma and a subtle tail. That would make sense for a small body, but this object is not small. Based on brightness measurements and reasonable assumptions about surface reflectivity, its nucleus could be around 10 kilometers across. That's enormous compared to Oumuamua and larger than Borisov. A body of this size should be violently active as it warms, yet it isn't. That contradiction has sparked intense debate. Is the comet depleted of volatile ice? Is its surface sealed by a thick, irradiated crust? Or are we seeing an entirely new category of interstellar object? Telescopes designed to monitor changes in brightness were brought in to help answer that question.
By tracking subtle variations over time, scientists could determine whether the object rotates and how its activity is distributed. The results added another layer of confusion. 3I Atlas rotates once every 29 hours. That's slow enough to imply structural stability, but its brightness barely changes as it spins, only about 0.2 of a magnitude. That suggests either a surprisingly uniform shape or a coma that masks the nucleus entirely. Either explanation challenges assumptions, and the deeper scientists look, the stranger this object becomes.
As 3I/Atlas continues its approach, more clues are emerging about its surface and history. Spectral analysis shows that the object is deeply red, even redder than many asteroids in our own solar system. This coloration is a signature of prolonged exposure to cosmic radiation. For billions of years, high-energy particles would have bombarded its surface, chemically altering its outer layers. That alone suggests an ancient origin. But velocity data takes that implication even further. Based on the relationship between stellar populations and velocity dispersion in the Milky Way, astronomers estimate that 3I/Atlas could be anywhere between 3 and 11 billion years old. That is an astonishing number. Earth is only 4.5 billion years old. The Sun itself is younger than the upper estimates for this object. If those calculations are correct, 3I/Atlas formed around a star system that existed long before our own. It may even predate the current structure of the Milky Way. In other words, this object is not just from another place, it may be from another era of the galaxy. That raises uncomfortable questions. If interstellar space contains objects like this, how many are out there? Early estimates suggested interstellar visitors were extremely rare, but those estimates were based on surveys that avoided the galactic plane. Atlas did not, and because of that, it may have revealed a bias in our observations. Interstellar objects may not be rare at all. They may simply be difficult to detect unless you know exactly where to look. That possibility has enormous implications. It suggests that material from distant planetary systems is constantly passing through our neighborhood unnoticed, that the solar system is not an isolated island, but a crossroads occasionally intersected by ancient debris from elsewhere in the galaxy. Comparisons with previous interstellar visitors only deepen the mystery. Oumuamua showed no visible coma but exhibited non-gravitational acceleration. Borisov was highly active, with strong dust production. 3I/Atlas sits awkwardly between them, active but subdued, large but quiet, fast but stable. There is no single model that explains all three, which means the category itself may be more diverse than we imagined. These are not variations of the same thing. They are fundamentally different objects, sharing only one trait: they do not belong to the Sun. And that realization is forcing scientists to rethink what interstellar space actually contains.
The final months of 3I/Atlas's journey through the solar system are now underway. As it approaches perihelion, scientists are watching closely for changes in activity, composition, and structure. Even small variations could help determine whether its surface is sealed, layered, or chemically unusual. But time is short. Once it swings around the Sun, it will accelerate outward and fade rapidly, becoming impossible to observe with current technology. Whatever secrets it holds must be uncovered now, or they will be lost for billions of years. For observers on Earth, the comet will become visible to amateur telescopes before briefly disappearing behind the Sun. After perihelion, it will re-emerge for a short time before vanishing forever into interstellar space. Tools that track its orbit allow anyone to follow its path in real time, watching an object that has wandered the galaxy since before Earth existed. This is not a story about aliens. There is no evidence of artificial origin here. What makes 3I/Atlas extraordinary is something far more profound. It is physical proof that planetary systems across the galaxy eject material into interstellar space, that those fragments survive for eons, and that, occasionally, they pass close enough for us to study. 3I/Atlas is a reminder that the galaxy is not static. It is violent, dynamic, and deeply interconnected.
Stars form, planets form, systems destabilize, and debris is cast outward to drift between suns. Most of it will never be seen, but this object was, and it arrived at a time when our instruments were finally capable of noticing it. When it leaves, it will carry its unanswered questions with it, but it has already delivered something invaluable, a glimpse into a part of the universe we cannot reach any other way, a fragment of a distant, ancient world passing briefly through our sky. Scientists are stunned not because it is mysterious, but because it is real, and because it suggests that what we have seen so far may be only the beginning.